What's going on, everybody? Welcome back to my YouTube channel. Now, this is another yet beautiful and nice Olympiad question we have here. And it says x minus 3 to the power of 4 is equal to 16. And we are told to look for the value of s. So the first thing we're going to do when we are faced with a question like this is to move the 16 inside. That means move the 16 to the left hand side. So let's do that real quick. So we have x minus 3 all raised to the power of 4. When 16 crosses to the left hand side, it becomes minus 16 equal to, now nothing will be remaining on the right hand side, so equal to 0. Now, this expression can be expressed like this: s minus 3 to the power of 2 all raised to the power of 2. Why? Because I know that from indices, whenever I have a base a raised to a power of m, and this is also raised to another power of n, the power does multiply each other. That means I'll be having m times n. So the power multiplies. So that means when this power inside multiplies this other power outside, 2 times 2 gives 4. So this expression we have under is the same as this one we have here. Minus. Now, 16 is a perfect square. And as a perfect square, that means we need to raise a number to a power of 2 to give 16. And what is that number? 4. So 4 to power 2 gives 16 equal to 0. Now take a look at this expression. Look at what I have on this bracket and this 4. You notice that what I have on this bracket is raised to a power of 2. And 4 is also raised to a power of 2. And there is a minus between them. Minus means difference. So this means difference of 2 square. A difference of 2 square, for example, can be expressed like, for example, when I have m squared minus n squared, difference of 2 square. So this is equal to m minus n, m plus n. So this is how to express difference of 2 square. So I'm going to be expressing what I have here, which is a difference of 2 square, like this. So let's do that. That means my m is this first expression on this bracket. So m is this and n is 4. So I mean this is my m and this is my n. So let's express it this way. Open a bracket. So let's do that. M, so our m is what we have here, which is s minus 3 raised to a power of 2. So that's my m, which is this, minus n. So minus n. What is our n? N is 4. So we're going to be writing 4 there. You close your brackets. Now open another bracket like this. Now m, what is our m? M is this. So we're going to be writing x minus 3 to the power of 2. So this is our m plus n plus n. N is 4. So we close our bracket. Equal to 0. Very good. I believe we are doing well on this case. Now, watch what we have now. What I have here is a factor and another factor equal to 0. Whenever you have an expression like this, as long as it is equated to 0, that what we have on the right hand side is 0, you can always do it like this. Bring this one on this bracket, which is x minus 3 all squared minus 4, which is what I have on this bracket, and equate it to 0. Or what I have on this other bracket, which is s minus 3 all squared plus 4 is equal to 0. Now we're going to be solving this one after the other. I'll be starting with this one, which means this one is my case 1. So I'll be writing case 1 here. So for case 1, I have x minus 3 to the power of 2 minus 4 equal to 0. Now I need to move this negative 4 to the right hand side. And when I do that, it becomes positive 4. So I have s minus 3 to the power of 2 equal to negative 4 crosses to the right becomes 4. Very good. So now the next thing for us to do is to take the square root of both sides. So I can cancel out this square. So let's take the square root of both sides. I'll take the square root of s minus 3 all squared equal to, I'll also take the square root of the right hand side. So I'll be writing plus or minus the square root of 4. So now notice the square can cancel the square root here. So leaving behind s minus 3 equal to, now I have plus or minus here. So what is the square root of 4? 2. Very good. Very good. So now let's continue. All right, so I'm going to be collecting like terms, which means I'll be moving this negative 3 to the right. So s will be equal to, when negative 3 crosses to the right, it becomes positive. Here I have plus or minus 2. So now I'm going to be separating this using the plus first. So s will be equal to 3, follow with the plus, plus 2. So 3 plus 2 gives what? 5. Very good. Now let's go with the one with minus. So s will be equal to 3. Now go with the minus, minus 2. So 3 minus 2 gives what? 1. So the values of s I have in this first case are 5 and what? 1. Very good. So now let's go to our case 2. What is going to be our case 2? So our case 2 is going to be this other one we have here, which is s minus 3 all to the power of 2 plus 4 equal to 0. So now let's get on with it. So this is our case 2. Now we need to collect like terms by moving this positive 4 to the right hand side. So I'll have s minus 3 raised to power 2 equal to, when positive 4 crosses to the right hand side, it becomes negative 4. So in order to remove this 2 or this square, we need to take the square root of both sides. So take the square root of the left hand side, which is s minus 3 to the power of 2 equal to plus or minus the square root of 4, negative 4. That's what we have here, negative 4. So we can see the negative very well. Now notice the square roots can cancel off the square, leaving behind s minus 3 equal to plus or minus. Now there is a negative inside the square root. So how do we treat negative inside the square root? We do it like this. The negative can be expressed as negative 1 times, now times 4. Are you seeing that? Very good. So this I have x minus 3 to be equal to plus or minus. Now there's something you need to know regarding this. I'll be doing this number first before coming to this negative 1. So what is the square root of 4? The square root of 4 is 2. So I'm going to be writing 2. Now coming to negative 1. What is the square root of negative 1? The square root of negative 1 is equal to I. So square root of negative 1 gives us I. So I'm going to be putting the I there. So this is a complex number. So let's collect like terms by moving this negative 3 to the right hand side. So I have s equal to, when negative 3 crosses to the right, it becomes positive. Now I have plus or minus 2i. Very good. Very good. So now I'm going to be separating this sign. I'll go with the plus first. So s will be equal to 3 plus 2i. So this is one value for s. This is a real number and this is a complex number. So let's go with the minus. Let's say or s will be equal to 3. Go with the negative minus 2i. So we see the values of s. We have 5 and 1, and we have 3 plus 2i and 3 minus 2i. You see, I believe you have learned something from this video. Don't tell me you didn't learn anything new. And I believe you also enjoyed this video. Well, if you really enjoyed this video and you want me to do more, go ahead to give this video a thumbs up, subscribe if you haven't, turn on the notification bell so you don't miss my upcoming video. And like I always say, until next time, take care.